Hello everyone, this is Mr. Zilich, and for this video we're talking about conditions for special parallelograms. And so when I was going through the notes here, I did not know whether to put definitions or equations or formulas, so I just put as fun facts, and we're going to use a nice little red today, it looks like. So our first fun fact is that parallelograms with diagonals that are congruent implies they are rectangles. And just again, this little guy right here, that means implies. So the next one is parallelograms with diagonals that are now perpendicular implies they are rhombuses. I even took the time, looked on Google, and the plural of a rhombus is either rhombuses or rhombi. You can use either one. Fun facts. Fun facts all around today. So using this information, we are going to do a pretty extensive example today, trying to find what kind of shape the graph will give us. So again, nice little example here. And we're going to use the diagonals to determine whether a parallelogram with the given vertices is a rectangle, rhombus, or square. We are to list or give all the names that apply. So again, just for example's sake, if we actually found the shape to be a square, we would also say that that is a rectangle. Again, just for example. So we are going to be given a couple points here. A will be 0, 2. B will be 3, 6. C is going to be 8, 6. And D will be 5, 2. And first off, we're going to graph this bad boy. And since all the points, and they are all positive, we're just going to use the first quadrant. So this is 9, I believe. 1, 2, 3, 4, 5, 6, 7, 8. And this is 8 up here as far as our scale. Our scale is going to be 1. That's our origin right there. And so let's graph these points. So our first point is A, 0, 2. So that's right on the y-axis, and that is A. B will be 3, 6. So over 3, 1, 2, 3, up 6. 1, 2, 3, 4, 5, 6, right about there. That's going to be B. C is 8, 6, 1, 2, 3, 4, 5, 6, 7, 8, up 6, so right where B is, about there. That's C. And then D is 5, 2, 1, 2, 3, 4, 5, up 2, right about there. So we're going to connect the dots here ever so nicely. So again, we can already tell that this looks like a parallelogram. I know my drawing is not exactly precise, but we can tell that it's a parallelogram. And just visually, I want you to kind of see, do you think this is a rectangle? Do you think this is a rhombus, a square, or just a plain old parallelogram? So just take a moment, kind of think about that for a second, and just notice that there are no right angles in this. So anyway, we need to prove what it is. So we're going to draw the diagonals in, because in our last slide there, we found that the diagonals are pretty important as far as proving what kind of shape this is. So again, I drew in the diagonals there, and now we need to find if the distances are going to be equal. That might give us some information. So first, I'm going to do the diagonal that is AC. So AC is going to equal, again, using the distance formula, 8 minus 0 squared plus 6 minus 2 squared. Again, we used the points A and C in our distance formula, and that again is going to be squared. This equals the square root of 8 squared plus 4 squared, which equals 64 plus 16. This simplifies to the square root of 80, and we can get that as the 4 square root of 5. So again, we have 4 square root of 5 as this distance of AC. Now let's try to find the diagonal length of BD. So BD, again, kind of in a similar way, we're going to do 3 minus 5 squared plus 6 minus 2 squared. That'll equal the square root of negative 2 squared plus 4 squared. That equals the square root. Again, negative 2 times negative 2 is 4 plus 16, which equals the square root of 20. And that equals 2 square root of 5. So in fact, 4 square root of 5 and 2 square root of 5 are not equal. And so we know that this will not be a rectangle or a square. Again, so 4 square root of 5 does not equal 2 square root of 5. So no rectangle or square. So now, we have one more shape to check, and that is it a rhombus? And so we need now to see if the diagonals are perpendicular or not. And how to do this, we're going to find the slope of the two diagonals and see if they are opposite reciprocals of each other. Again, an opposite reciprocal is basically the number flipped, and then you add a negative to it. And so, for example, if we had 1/3 as our slope, the opposite reciprocal would be negative 3. So as I delete all our nice little distance right there, I guess I can't delete anymore. Scratch that out real quick. We're going to see if the slopes are opposite reciprocals. So we're going to take the slope of AC, and again we do rise over run. So slope of AC equals 6 minus 2 over 8 minus 0. Again, rise over run. So this would be our y2 minus y1, x sub 2 minus x, x sub 2, yes, minus x sub 1. And that equals 4 over 8, which equals 1/2. And the slope of BD equals 2 minus 6 over 5 minus 3. And simplifying this, we get negative 4 over 2, which equals negative 2. And now you can see that these two are opposite reciprocals, and therefore, by our nice little fun facts, the figure ABCD is a rhombus. And so now we know that it's not a square, it's not a rectangle, and it is a rhombus. Therefore, going back to our directions, we can name it as a rhombus. Thanks for joining us today. As always, this is a Mr. Zillage production. Have a good day, everybody.